This is a list of URLs I have referred to prepare the presentation. I am thankful to the people for helping me this presentation. Data is the foundation of machine learning applications. So understanding the data is very much required. Once we have got the number of features, then we have to identify how these features are related among themselves. We can use a correlation, regression, using different statistical algorithms to find out how these are related. It may be strong or weak or positively or negatively. Those kind of information we have to derive. Then only we can move on to the next step. Usually, understanding the data, cleaning the data, and preparing the data for the data analysis, these kind of steps usually take around 70% of our effort in developing the machine learning applications. When we have a data set, first we have to identify what are the variables available and what are their types. First we have to identify the target variable and the remaining predictor variables that can be utilized for our analysis. It can be discussed with an example. In the Excel sheet that contains the information about the student, we are considering play cricket as the target variable that shows whether the student is going to play cricket or not. The type of variables are the target variable is play cricket and the predictor variables are gender, previous exam marks, heights and weights. And when we are considering the data type in the data set that is given to us or that we have collected, and the student ID and the gender are in the character data type, and the remaining four are in the numerical data type. In data analyst, we can consider only the categorical variable and continuous variable. When compare this one, we have got a categorical variable as gender and play cricket. Even though play cricket is in the numerical data type in the original data set, but for our analysis it needs to be converted into categorical variable. And in the predictor variables, previous exam marks, height, weight are continuous variables. Based on these kind of categories, we can use our different analysis methods. Then we will move to the analysis. Before moving to analysis, there would be the two kinds of analysis. One is univariate analysis, another one the bivariate analysis. In the univariate analysis, we will consider the variable itself. The singular variable will be considered. We can find out how it is available in our data set and the observations available in our data set. And what kind of analysis we are using based on the category of the variable. If it is a continuous variable, then we will use center tendency and how the data spread around the center tendency. That kind of analysis we can do if it is a continuous variable. So, and the center tendency can be revealed through mean, median, mode, or minimum and the maximum, and the spread can be found out by the range. The range is the difference between the minimum and the maximum, quartile, interquartile range, variance, standard deviations, skewness and quartiles. These are all some of the measurements that can be used to determine the spread across the data. And for visualization, we can use either histogram or box plot. In box plot, it shows and the median, first quarter, third quarter, and upper and lower limit, and it also shows any outliers if it presents in our data. And the histogram shows how the data is distributed. The distribution in the sample, it is a normal distribution shows, but it is very difficult to find a normal distribution. So we can understand what kind of distribution for that particular continuous measurement in our data set using this histogram. Or if we want to convert data so that we can get the normal distribution, for example, considering log of the data, then we can take it later. So we have to identify how the data is distributed in our data set for this continuous variable. If it is a categorical variable, we can use the frequency of table. For every category variable, for example, how many frequency in the male students, or how many frequency in the female students. So that kind of frequency table we can use to analyze the categorical variable. In case of bivariate analysis, instead of analyzing the variable singularly, we have to consider two variables at a time. The variables in the two variables may be any type of continuous or categorical. So it may be continuous and continuous, categorical and categorical, or categorical and continuous. In case of continuous and continuous, we can use the scatter plot as a visualization. So when we have the measurement, continuous measurements, the scatter plot shows the relationship between these two continuous measurements. So for example, in the first column, it shows a strong positive correlation. The reason is, if we draw a line across the points, then the point in the data points around the line is very close. The data points are very close to the line. So it is a strong positive correlation. It starts from the lower left corner to upper right corner. So it is a strong positive correlation. The next one is, it has a positive correlation, but it is not that much strong. The reason is, when you draw a line, not all the observation points are closer to the line. So it is a positive correlation, but at a moderate rate. And the third one shows no correlation among the two measurements. Likewise, in the below shows in the negative correlations, because the data points starts from upper left corner to lower right corner. So it is a negative correlation. The first one is the moderate, and the second one is the strong negative correlation. The third one is the curvilinear relationship. So through this scatter plot, we can understand whether the two continuous measurements have linear relationship or non-linear relationship. That will help us to consider these measurements, how we are going to utilize these two measurements. If it is categorical and categorical, then we can use two-way tables and the chi-square methods to find out the relationship between these two category variables. In the two-way table, in the two-way tables, one category variable is shown in rows and another one is in the column, and the cell shows the count and the count percentage of these categories. For example, the first one is 1 and the small, we have got only 1, and the percentage is 11.11%. So this kind of information we can find out through the two-way tables. To find out the strength, we can use the chi-square methods. If the probability is 0, then the two variables are dependent. If the probability is 1, then the two variables are independent. If any value between these two, then we can find out whether it is how much independent or independent. Usually we can use a value of 0.05 as the significant value. If any value below 0.05, then we can say that with a 95% confidence these two variables are dependent. That kind of information we can derive through the chi-square methods. And for categorical relationship, we can use stacked column graph to find out the relationship, to visualize the relationship between these two categorical. And in case of categorical and continuous, we can use the box plot. The box plot shows how the categorical variable and the continuous variables are related. It also shows the any outliers for the particular category in the box plot. And that shows the relationship between these two. To find out the strength, we can use z-test, t-test, or ANOVA. And the z-test shows the statistical significance between the average of two groups. If it is small, then the average, the difference of average is statistically significant. Likewise, we can also use t-test, and the only consideration is if the observation is less than 30, then only we are going for a t-test. In case of ANOVA, we can determine the statistical significance of more than two groups. Once we have analyzed all this data, then we will move to the missing value. Why we have to consider missing value is, for example, we can easily remove the missing value, but that will reduce the accuracy, or that will reduce the power of our model. If the sample size is very small, then deleting missing value is not at all solution. So we have to consider some kind of treatment for the missing values. How the missing values are influencing our data, we can find out with the example. The first spreadsheet says first spreadsheet says contain missing values. With the missing values, we can find out that at the bottom we can find out the result that the number of male students who are playing cricket is higher than the number of female students. But when we are inputting the data with the proper strategy in the right spreadsheet, we find that the number of female students playing cricket is higher than that of male students. So this kind of influence we can have missing values. If we are not treating the missing value properly, then the result we will get is inaccurate, and the power of model we are also losing. So we have to take some kind of proper treatment to impute the missing values. So what are the methods available to impute the missing values? The first one is deletion. As I have already said, if the sample size is too high, then we can delete those observations, because we are going to consider as a small sample for our analysis. So if the sample size is thousands of 10,000 or 20,000 records, then we can consider either deleting the observations, or if the row contains more missing value for a number of features, then we can delete that kind of observations from our data set. The next one is we can use a known relationship in case of mean, median, mode imputation. If it is a continuous measurement, we can use the mean or median to impute the missing values. For example, we can calculate the mean or median for non-missing values, and that value can be imputed to the missing values. It can be two types: generalized mean, or similar case method. In generalized, instead of considering any group, we calculate the mean or median of the non-missing values, and that value will be imputed to the missing values. In case of similar case, for example, we can calculate the mean for all the male candidate with the non-missing values, and those values can be imputed for missing values of the male candidate. The same method is used for female students also. And the mode imputation is for categorical variables. So high frequency value can be imputed to the missing values. And the next one is the predictive model. It is a sophisticated model. We can build up predictive model to input the missing values. In this case, the data set can be split into two. One with non-missing values and another one with missing values. The non-missing value data set can be used as a training methods to develop that model. Once the model is available, then the model can input the data to the missing values. And another one thing is we can also consider the relationship among the category variables or continuous and category variables to derive more information to input the missing data. These are all the methods available to input the data. We have to take a proper strategy for every measurement to input the missing data before moving to the next step. Outliers. Treating outliers is also a very important step, because outliers gives inaccuracy in our measurement, statistical measurement. Even in average or everything, it gives inaccuracy, and the model is also biased because of this outliers. So we have to have a proper treatment of outliers. To understand outliers, we can come up with the example. For example, we are considering the salary of IT people with 10 years of experience. We have collected the data and find out that the average salary would be 12 lakhs per annum. But however, two employees have salary as 40 lakhs per annum and 45 lakhs per annum respectively in certain companies. These two values are compared with the rest of the population is too high. So if these values can be outliers, we have to come out with the proper methods to handle this kind of outliers before moving into the building of the model. Here we can see that in the height we don't have any outliers, and in the weight we don't have any outliers also. However, when consider these two are together in the scatter plot in the third plot, we found three outliers. One is in the upper side and two are on the lower side of the observer points. So we have to use the proper methods to handle the outliers. What are the methods available to handle the outliers are the same as missing values. We can either delete the observations or transform the observations or do some other activities, or we can have a different group of outliers together in a different data set. That kind of different methods we can use to handle the outliers. Now I come to the collecting data. Actually, it is the first step. We know very well collecting data. Then why should I come at this point is we are going to discuss about the feature selection that is very much connected with this collecting data. So while collecting the data, we have to first we have to find out the target. Once the target is available, all the relevant data will be collected. The relevant data may be in the database of the particular department of organization, or the data of the organization, or it can be outside the organization from social media or sensor or any internet. So we can consider all the available input data after discussing with the business users. Now we have got hundreds of features. So hundreds of features. Then we are coming to the point that whether we are going to consider all the features for our analysis. Here comes in the feature selection. We should not consider all the features. The reason is the variables may have the same the redundant influence on the target variable. For example, we have to remove the redundant variable, otherwise it will reduce the accuracy. At the same time, we have to include the very influencing variable into our data set that will increase the accuracy. If we find any redundant variables, that can be eliminated to improve our accuracy of the model or to improve the power of the model, for which we have to discuss with the business whether we are going to remove this or what is the effect if we are removing this variable. That is one point. And after which we can also use algorithm. There are plenty of algorithm available. Using that we can find out the influence of the variable to the target variable. Based on the result, we can remove the some redundant variables, and we can also consider, we can remove the low influencing variables from our analysis. And there is another one point: instead of using tens of low influencing variables, we can consider one or two PCS, principal component analysis, so that will collect all the influence from the low influence variables, and instead of using tens of variables, we can consider one or two pieces in our analysis. So these are the some way to reduce the number of features. And what is the reason? Another one reason is if you have too many variables, then the model will struggle to find out the pattern behind the data. So if there is a possibility of overfitting with the training data, so the number of features needs to be reduced so that the model developed could avoid the overfitting. So this is another one reason why we should reduce the number of features. And the third reason we can say is we obviously know that if we have a number of features too high, then the competition would be very slow, and we have to consider high configurable hardware for this computation. So these are some of the reasons we have to reduce the features, and we have to select the appropriate features for our analysis to build up the model. Thank you. This is the end of this presentation, but we will have another one presentation. In this presentation, we are going to discuss with Kaggle competition, with an example of Kaggle competition, to discuss all these points what we have discussed, what we have covered in this presentation. Thank you again.